Welcome to Selfie Story, where we unravel the mysteries of the universe. Today, we dive into the enigmatic world of Pluto, a celestial body that has raised more questions than answers. As we embark on this journey, let's take a moment to clear up some common misconceptions about Pluto. Is it a planet? Is it not a planet? The debate has raged on for years, causing quite a stir in the world of astronomy. So, let's set the record straight. Pluto, named after the Roman god of the underworld, was discovered in the year 1930 by Clyde Tombaugh, an American astronomer. Upon its discovery, it was promptly classified as the ninth planet of our solar system, joining the ranks of its bigger brethren like Jupiter and Earth. However, this title was short-lived. In the year 2006, the International Astronomical Union, or IAU, introduced a new definition for what constitutes a planet. According to this new definition, a planet must orbit the Sun, be spherical in shape, and have cleared its orbit of other debris. While Pluto met the first two criteria, it fell short of the third. Its orbit is populated with numerous other objects, part of a region known as the Kuiper Belt. This led to Pluto's reclassification as a dwarf planet, a decision that sparked controversy and debate among astronomers and the public alike. Some argued that the new definition was too restrictive, while others maintained that it was necessary to distinguish planets from other celestial bodies. Despite its demotion, Pluto continues to captivate us with its icy landscapes, intriguing moons, and its heart-shaped glacier, known as Tombaugh Regio. It's a world that is far more complex and fascinating than we once thought. So, contrary to popular belief, Pluto is not a full-fledged planet, but a dwarf planet that continues to intrigue astronomers and space enthusiasts alike. Now, how dark do you think it is on Pluto? A common misconception is that Pluto is an utterly dark world due to its distance from the Sun. You'd be forgiven for thinking that Pluto, being roughly 40 times farther from the Sun than Earth, is shrouded in an eternal night. But here's the thing. Even though it's way out in the chilly fringes of our solar system, it's not pitch black on Pluto. Imagine the faint light of the far-off Sun reaching out across the cold void of space, touching Pluto with just enough illumination to cast the landscape in a perpetual twilight. That's right, a day on Pluto would actually appear as though it were dusk here on Earth. It's a weak light, no doubt, but it's there, and it's enough to light up the icy landscapes of this distant world. So how does this happen? Well, sunlight, being made of photons, travels in all directions and doesn't just stop because the Earth is in its path. It keeps going, spreading out into the universe. By the time it reaches Pluto, it's significantly diluted, but it doesn't disappear entirely. It's like being in a room lit by a single candle. The light may be faint, but it's there, and your eyes would adjust to see in that light. So imagine standing on Pluto's surface. The Sun would seem incredibly small, like a bright star in the distance. The landscape around you would be dimly lit, like a twilight scene here on Earth. The icy surface would reflect and scatter the sunlight, creating a diffuse glow that lights up the Plutonian landscape. But don't get it twisted. This doesn't mean you'd be catching a tan on Pluto. The sunlight there is around 1,000 times less intense than it is on Earth. You'd still need to bundle up to withstand the extreme cold. So while it's not a bright, sunny day, Pluto is not shrouded in complete darkness as many believe. Have you ever wondered how Hubble can see distant galaxies clearly, but not Pluto? This question may seem counterintuitive at first, but the answer lies in the unique characteristics of our cosmic backyard and the impressive technology of the Hubble Space Telescope. Firstly, let's look at the size. Pluto is exceptionally small, especially when compared to the vast galaxies that Hubble observes. Its diameter is just about 2/3 that of Earth's moon. That's smaller than many of the moons in our solar system. This tiny size makes Pluto a difficult target for Hubble's gaze. Brightness is another key factor. Hubble has a distinct advantage when it comes to observing distant galaxies because they're incredibly bright. They're composed of billions of stars, each emitting their own light. Even though these galaxies are far away, their combined brightness makes them visible. On the other hand, Pluto, being a solitary and non-luminous body, doesn't shine with the same intensity. It simply reflects sunlight, and due to its distance from the Sun, that reflected light is relatively dim. Finally, let's consider proximity. You might assume that because Pluto is closer to us than the distant galaxies, it would be easier for Hubble to see. But in reality, the opposite is true. Imagine trying to take a detailed photograph of a tiny, dimly lit object that's in constant motion. That's essentially the challenge Hubble faces when trying to focus on Pluto. The distant galaxies, on the other hand, are so far away that their motion is imperceptible to Hubble, making them easier to photograph in detail. To wrap it up, the difficulty Hubble faces when trying to observe Pluto is not about the distance. Instead, it's a combination of Pluto's small size, its lack of brightness, and its relative closeness that make it a tough target. So it's not about distance, but about size, brightness, and proximity that makes Pluto a challenging target for Hubble. Did you know that Pluto doesn't orbit around Charon, and Charon doesn't orbit around Pluto? They both orbit around a common point in space. This point is known as the barycenter. For most planet-moon systems, the barycenter lies within the planet, hence giving us the impression that the moon orbits the planet. But with Pluto and Charon, things are a bit different. The concept of a barycenter is quite fascinating. It's the center of mass of two or more celestial bodies that are orbiting each other. It's the point about which these bodies appear to orbit, the balance point, if you will. In the case of Earth and our moon, for example, the barycenter lies within Earth's crust, making it seem like the moon is orbiting Earth. However, when it comes to Pluto and Charon, their sizes and proximity to each other result in a unique interaction. You see, Charon is about half the size of Pluto, and it's much closer to Pluto than our moon is to Earth. The barycenter of the Pluto-Charon system is actually located outside of Pluto, in the space between them. This means that as Charon orbits the barycenter, Pluto does too, albeit in a smaller circle. From a distant perspective, it would appear as though Pluto is wobbling around a point in space, while Charon is doing a larger orbit around the same point. It's like a cosmic dance where both partners are tethered to an invisible spot on the dance floor, moving in harmony with each other. This unique dance, this shared gravity, is what allows Pluto and Charon to always have the same faces towards each other, much like our moon does with Earth. It's a phenomenon known as tidal locking. In the grand cosmic ballet, Pluto and Charon are indeed a standout couple, their dance defying the conventional understanding of orbits. So in a cosmic dance, Pluto and Charon revolve around an invisible point in space, defying our conventional understanding of orbits. To wrap up, let's debunk one more misconception. Many believe Pluto to be a dull, icy world with no significant features. But as it turns out, this tiny celestial body is far more intriguing and varied than we ever imagined. NASA's New Horizons mission, which flew by Pluto in 2015, unveiled a world teeming with remarkable landscapes. One of the most striking features is a massive, heart-shaped glacier known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto. This glacier, composed mainly of nitrogen ice, is about the size of Texas and Oklahoma combined, making it one of the largest known glaciers in our solar system. And that's not all. Pluto also boasts towering mountain ranges, some as high as the Rockies. These mountains aren't made of rock like here on Earth, but rather of water ice so cold and hard it behaves much like rock. Imagine, icy peaks reaching up into a sky bathed in the faint, distant sunlight, a sight as beautiful as it is alien. But Pluto's surprises don't end there. The tiny world may also be home to cryovolcanoes, or ice volcanoes, that erupt with a mixture of substances such as water, methane, or ammonia instead of molten rock. These cryovolcanoes, if confirmed, would be yet another testament to Pluto's dynamic and active geology. Other features on Pluto's surface include vast plains, dark regions crisscrossed with valleys and ridges, and areas marked by pitted terrain, thought to be caused by the sublimation of nitrogen ice into the thin Plutonian atmosphere. So, far from being a featureless ice ball, Pluto is a fascinating world with a surprisingly complex and diverse landscape. It's a testament to the wonders of our solar system, a reminder that even the smallest and most distant bodies have stories to tell, secrets to reveal, and mysteries to unravel. And remember, in space, there's always more than meets the eye.